This video is a first type of sample problem for Newton's second law. Now remember that Newton's second law is actually the summation of forces would be equal to mass times acceleration, or F net would be mass times acceleration. Now, two tugboats push on a barge at different angles. The first tugboat exerts a force of 2.7 times 10 raised to 5 in the x direction, and the second tugboat exerts a force of 3.6 times 10 raised to 5 newtons in the y direction. Now, the mass of the barge is 5 times 10 raised to 6 kilograms, and its acceleration is observed to be at 7.5 times 10 raised to negative 2 meters per second squared in the direction shown. Now, we are going to calculate the drag force of the water on the barge resisting the motion. When we say drag force of the water on the barge resisting on the motion, this is actually the force that resists with the total force or F net at the same time the force applied of both forces as F1 and F2. Now to calculate for the applied force exerted by F1 and F2, we're going to use Pythagorean theorem later. And to illustrate how this figure got this angle at 53.1 degrees. Okay. Now let's proceed with the free body diagram of our FBD, which is required in every solution for this type of problem. As we are going to illustrate the forces exerted on this system, okay, F1 now, since the first tugboat moves towards the x-axis and it is also moving towards the east, whereas the second tugboat towards the north. And the drag force Fd is actually the resisting force of F net and force applied. Okay. Later, we're going to balance forces on this side or on this hypotenuse. But first, we need to solve for the F up. Solving now for the applied force or F up, we're going to apply Pythagorean theorem. Now let's proceed with the solution. We are given with F1, F2, mass of the barge, and the acceleration of the barge, as both F1 and F2 exerts force on moving the barge. And we have the unknown as the force drag. Now, the force drag is the resisting force of both F net and F up. Now, let's proceed with the numerical solution. Now, when we say F up, it pertains to the resultant forces of F1 and F2, or the hypotenuse of both F1 and F2 forces. Now, F up is equal to the square root of F1 squared plus F2 squared. Substituting the values or plugging in the values gives us the square root of the quantity of 2.7 times 10 raised to 5 newtons squared plus the quantity of 3.6 times 10 raised to 5 newtons squared. Now, this numerical values gives us the force applied equivalent of 4.5 times 10 raised to 5 newtons. Now, how did we get our measured 53.1 degrees of the angle here? Now, this is actually dependent to the force 1 and force 2. Since in this illustration, FBD, force 1 and force 2 are the adjacent and opposite sides of F up. Now, if we are given with values for the adjacent and the opposite sides, okay, this is equal to tangent of the angle, which is the ratio of the opposite side all over adjacent. Now, getting the angle would be, we're going to use the reverse tangent or arctangent or inverse tangent of F2 all over F1. Now let's proceed with the substitution of the values, as the arctangent of 2.7 times 10 raised to 5 newtons all over 3.6 times 10 raised to 5 newtons, or this is in equivalent of 53.1 degrees. Now let's proceed with the summation or balances of forces. Okay. Now if we're going to solve for the F net, okay, F net minus F up is equal to FD. Or manipulating the whole equation, this gives us the net force is equal to F up minus the drag force. Okay. Now, when we say Newton's second law, since this barge exerts an acceleration of 7.5 times 10 raised to negative 2 meters per second squared, the summation of forces must be equal to mass times accelerations, since the problem entails acceleration here. So F net, or the net force, is equal to the applied force minus drag force, which is also equal to mass times acceleration, or mass of the barge times acceleration of the barge itself. Okay. Further simplifying the following gives us Fd is equal to applied force minus mass times acceleration of the barge. Or if we're going to substitute the following values, since we already solved for the applied force, which is the Pythagorean theorem, or the Pythagorean forces, or the hypotenuse force of F1 and F2 at 4.5 times 10 raised to 5 newtons, minus the following quantity as the mass of the barge at 5 times 10 raised to 6 kilograms, multiplied with the acceleration of the barge at 7.5 times 10 raised to negative 2 meters per second squared. Or finalizing the following as 7.5 times 10 raised to 4 newtons, or 75,000 newtons.